And in part B, suppose you continue flipping the coin for a total of k times. You flip a coin a total of k times, and after picking it, you see k heads. Now, what is the conditional probability that you pick the fake coin? Okay, so in this question, you still go into your bag, you pick a coin up, you take the same coin, you flip it k times, you observe that on all those k times, you have got a heads. What is the probability that you actually happen to have picked the fake coin? So the probability of you having picked the fake coin, given that you have observed heads actually occurring k times, is equal to the joint probability distribution of fake happening and having observed heads k times, given the probability of heads happening k times. Okay, now the joint probability distribution, again, as you saw from the last video, is equal to the probability of heads occurring k times over the fact that the coin is fake to begin with, times the probability of the coin actually being fake divided by the probability of heads being observed k times. Okay, so at this point, I can see that the probability of heads occurring k times, given that the coin was fake, that data I already have with me, which is if the coin was fake, how many times would I see heads occurring k times? Well, that's going to be exactly 1, because the fake coin has heads on both the sides of its coin. So that's exactly going to be 1 times the probability of you selecting a fake coin. The probability of me selecting a fake coin is actually 1 over n. Okay, divided by the probability of me seeing heads occurring k times. So this is occurring k times. Okay, this entire thing is equal to the probability of fake, given that you have observed heads occurring k times. Okay, so now if I draw a Venn diagram here, okay, again, to kind of give you the intuition, what's happening is if I draw a Venn diagram here, which is my omega, my universal space is my omega, that contains the results, that contains the entire set of all possible results that can happen from my experiment. Now, what's the experiment here? Well, the experiment here is I've taken a coin and I've flipped it k times. So what is it that I'm going to observe in my experiment? Well, what I observe in my experiment is the number of times heads happens. So at some point, you will see that, okay, here are, again, I'm just being rough. These are all the times when you can see heads can happen exactly 1. Well, these are times when you can see that heads can happen exactly 2. Heads can happen exactly 2 times. And so forth. And at some point over here, you're going to see, all right, here's the probability of heads actually happening k times. Okay, so let's say this is some probability of heads actually happening k times. Heads happening k times. Okay, now you know that some of these coins are fake and some of the coins are not fake. So what I'm going to do here is I'm just going to draw some kind of a picture. Let's say this is my set over here that says, all right, everything inside here represents the event which is not fake. Okay, and everything outside the circle represents the event where the coin that you chose was fake to begin with. So what's the probability of you actually seeing heads occurring k times? Well, the probability of heads occurring k times, which is this piece in yellow, is nothing but equal to the probability of heads occurring k times and everything over here. So let's add up. Let's get the probability of this entire yellow piece as the addition of 2 things. The addition of this blue piece. Okay, what's this blue piece equal to? Well, the blue piece is equal to heads of k occurring and the coin being not fake. Okay, what is this entire piece in pink equal to? Well, this piece in pink, which is this piece over here, and this piece over here, both these pinks together is nothing but the probability of heads occurring k times and the coin being fake. And when I add them up, I'm going to get back this entire yellow strip, the entire yellow shaded strip, which I had earlier, which is nothing but the probability, this entire thing is equal to the probability of heads occurring k times. Okay, so what is this piece equal to? Well, this piece in green is nothing but this piece over here, which is exactly the same piece as this. So you already have that value. You already have this is equal to 1 over n. Okay, then what is this piece going to be equal to? P of heads of k occurring and the coin actually being fake. Well, this piece over here is going to be equal to the probability of heads occurring k times, given that the coin is not fake, times the probability of the coin being not fake. So the coin is not fake. What's the probability of you observing k heads? If the coin is not fake, the probability of observing a single head is half. But because I'm doing this experiment k times, it's going to be half times k. Half to the power k, half to the power k is the probability of you actually observing exactly k heads if the coin was completely fair, times the probability of the coin actually being not fake. Well, the coin being not fake, the probability of the coin being not fake is 1 over n. I have a total of n coins and one of them happens to be not fake. So I've got everything now to calculate my requirement. So this piece over here is I've already calculated this green box over here. I can add it together. To get my denominator. And the moment I get my denominator, I already have my numerator over here, which is 1 times 1 over n, and I can simply get the probability now of what's required of fake, given that I've observed head having occurred k times.